All right, so for the first question there, it says the score of 51 students in mathematics examination are presented below. Do we all have the past question? Can you please help me snap it and post it online so everybody will have it? Because it's better we see it so we can easily understand. You can use Cam Scanner. Use Cam Scanner to be clearer there and convert it to PDF. All right. So it says the scores of 51 students in mathematics examination are presented below. So here we have the data, the raw data, 63, and so on and so forth. The first one there says we should construct a frequency distribution for the data using the interval 21 to 30, 31 to 40, and so on and so forth. So very simple. For you to construct the table of the first question, the cumulative frequency distribution, we basically start with the class interval. Class interval. And from the question you have been given, but in case you are not given the class interval, how do you get your class interval? Basically, when the numbers are more, that is the distribution, when they are more than 15 or 20, you make use of a class width of 5. Thank you very much. When they are much more, then you can make use of 10. Do you get that now? But in this case, we have been given, we have to use 21 to 30. You can see the class width there is 10. But that is between 21 and 30, you have to 10 numbers, 21, 22, 23, 24, 25, and so on and so forth. So let's just go with that. So for me to know where to stop also, I'm going to check the highest number I have there in the distribution. Are you getting it? So let's check the highest number there. What's the highest number we have there? 95. So that means whatever I'm going to do, I'll make sure 95 is included in the class interval, right? So let's start with the first one, 21 to 30, 31 to 40, 41 to 50, 51 to 60, 61 to 70, 71 to 80, 81 to 90, and 91 to 100, so that it can contain that 95 that is the highest figure there. I hope this is clear. All right, now let's move on. We can see that this question is actually asking us to find mean, standard deviation, and so many other things, right? Now, you don't need to cram how the table is going to look like. It is from your formula, you will know what to put on the table. Are you getting it? Now, you recall, what is the formula for mean? The formula for mean is what? That's summation fx over what? Summation f, right? Where f is standing for the frequency, x in this case is going to be your midpoint because it's a group data. How do I know it's a group data? There are ranges between these numbers, this to this, this to this. So this is a group data. Assuming these numbers are standing one after the other, 1, 2, 3, 4, 5, that's on group data. Do you get that now? So I have summation of fx, that's the summation of the frequency multiplied by the midpoint, which is this x, divided by the summation of f, the total frequency. That means in that case, from this my formula, this is what I'm going to use to create my table. So in this table now, I need f, right? That is, before I can get fx, I'll need to find f, I'll need to find x, then I'll need to multiply them together and find the total. That's what is going to be on your table. Do you get that now? So let's take our first one now, which is the midpoint, which is standing for our x, right? How do I get the midpoint? Midpoint is simply the average of these numbers. This, the lower class limit, plus the upper class limit divided by 2. The same thing with this, the same thing with this. But once you've gotten the first two, you will be able to easily manipulate the remaining. You don't need to calculate anything again. So let's get the first two. 21 plus 30 is what? 51 divided by 2. So I have 25.5. Then let's do the second one. 35.5. Now you will notice that the difference between these two numbers is what? 10. Automatically, I don't need to calculate anything again. This is just going to be 45.5, 55.5, 65.5, 75.5, 85.5, and 95.5. I believe this is clear to everyone, right? I hope it is clear. Okay, now let's move on with my table. Now, on my table, I've gotten x. That is out of it, right? Now, I need to find f. F is standing for the what? Frequency. Is it not?
So, I believe we all know how we got it, right? No, not at all. Alright, that's 1 to 15. What answer is that? What's 1 to 15? 7. 51 to 60. 61 to 70, I didn't complete. 10. 71 to 80. 71 to 88. 7. 91 to 100. 21 to 60. Yes, but I have 9. 9. Yes, I have 9. 9. 51 to 60 is 9. And then the last one. 3. Alright. Now, before we move on, let's check if our work is correct. That is the figures we put on the project. It must give us the total number of data we have here. Remember, we are told we have 51 students, right? So the addition of all these things, which is the summation of F, is meant to give us 51 also. If it's not giving us 51, that means we made a mistake somewhere. So 2 plus 5 is 7, right? 14, 23, 33, 41, 48, 51. Is it not? I hope that is clear. Now, if I look at this now, you can see I'm through with this summation of F. Now, what am I left with is summation of Fx, right? I've done F, I've done X. What am I left with? Fx. For my next table now, I'll simply put Fx. Right? What is Fx? Just the multiplication of F and X. That is, F times X will give me Fx. Therefore, 2 multiplied by this must give me the answer here. This multiplied by this must give me this. This times this, and so on and so forth. So 2 multiplied by 25.5 give us what? 3151. 5 multiplied by 35.5. 177.5. 7 multiplied by 45.5. 3. 188.5. Okay, 9 multiplied by 55.5. 499.5. 499.5. 10 multiplied by this, 6.5. 8 multiplied by this, 604. 604. 7 multiplied by this, 598.5. And then 3 multiplied by 95.5. 286.5. 286.5. Right? I've done my fx. I'll go back to my formula. What do I need this fx? I need it to find the summation of it. That is, I need to find the summation, the addition of all the figures I have there. So let's add up all these things together. Summation fx. 51 plus this. Please, you have to be careful by pointing the calculator. All these figures can be confusing sometimes. Very, very confusing. 3189. 3190.5. Okay. 3190.5. Right? So with these two details now, I can easily get the mean. First question there. Right? So let's get our mean. Mean is summation of fx divided by summation of f. What's the value for summation of fx?
I think the main thing here is to get how to do it. Once we know how to do it, the figures, you can easily, when you get to the exam, or you make sure you take note of it, please. In order not to waste our time, we still have a lot of things to do. Yes. All right. So now let's get our deviation. Deviation is the midpoint minus the mean. So I'll come to my midpoint. The first midpoint is 25.5. And I'll subtract it from the mean I got in this place, 62.56. So 25.5 minus 62.56 will give us what? Note, you are not going to use 62.56 minus this. It is the way it is written here, you're going to subtract it. Although at the end of the day, it might not matter because you're still going to do the square. It will give you positive at the end of the day. But follow the way it is. So I'm going to have 25.5 minus 62.56. What do we have there? Minus 30. Okay. The next one, 35.5 minus 62.56. Minus 27.06. 45.5 minus 2.56 minus 17.06 55.5 minus this, minus 7.06. 65.5 minus this, 2.94. 75.5 minus this, 12.94. This one will be 22.94, and then 32.94. I hope this is clear. Okay, now let's move on. Remember, it is not just D I need, right? Remember, this is standing for I need. What do I need next? D squared. Do you get that? So you see that you don't need to cram this table at all. Just know the formula. Once you know the formula, follow it that way and you're good to go. So I need D squared. For my table, I'll put D squared, or simply put it as X minus mean all squared. What does that mean? Means you're going to square each of these numbers. That's minus 37.06 squared. Note, when you do the square of minus, it's going to give you plus. That's why I said it might not matter at the end of the day. So everything eventually is going to be positive. So what's 37.06 squared? 1. Okay, 27.06 squared. Okay, I need to make it bigger. Are you sure? Okay, 17.06 squared. Okay, 1.06 squared. Okay, 2.94. Okay, 20.94 squared. Okay, 32.94 squared. Are you sure it's 104? Okay, let's move on. Now, the next thing I need again, I'll come back to my formula. I need f d squared. Is it not? That is the frequency multiplied by the square of the deviation. So on my table now, I'm just simply going to put f d squared, or f multiplied by the x minus the mean square. Please, I hope we are all getting what we are doing. Yeah, so you multiply the frequency times this answer here. That is it. So what is 2 multiplied by 1373.4? Okay, 732.24 multiplied by 5. Okay, 291.04 multiplied by 7. 20.28. Okay, 49.84 multiplied by 9. 8.64 multiplied by 10. Okay, that would be 6.4. So 167.44 times 8. Okay, 5 to 6.24 multiplied by 7. Okay, and then 1085.04 multiplied by 3. All right. Now we are through with that. Looking at my formula, I think I'm through. So I just need to find the addition of all these figures to find the summation fd squared. So underneath it, it's just going to put summation fd squared. So we add all these things together. Okay, so these are value of summation of fd squared, right? So now looking at my formula, is there any other thing to add to the table? Nothing else, right? So we just insert these values into the formula and get our answer. So our standard deviation, like the formula says, is the square root of summation f d square, which we've gotten here as 17258.64 divided by summation f, which is what? 51, right? So our standard deviation is the division, right? 23. Okay, so find this one. It's 18.390, so we can simply say 18.4, and that's the standard deviation. I hope the process is gotten by everyone. Note, the value here, it might not be correct, but getting the process of how it is done is the main thing, right? All right, so can we move on? The next one says we should find the variance, right? The coefficient of variation. I think everybody can do that. Variation is simply the square of your standard deviation, and that is all. Yeah, just square this answer, that's all. Variance is the square of standard deviation. Yes. Standard deviation, not square root of square. Yes, that is power of 2. Yes. To be the answer inside that place. 0.40. 18.4. The square of the variance. The square of standard deviation is variance. Please, is this clear enough? All right, so we are through with the beginning now. Now let's move on to, all right. Finally. Yes. We replace x minus min with v. No. I only wrote this to make the formula easier to understand. This is the main one it gave inside the textbook. But then normally, mathematicians, they all know x minus min is the deviation, and they represent it with d. Do you get that now? So in case you cannot put this in your memory, summation f into x minus min all square, you can also say summation f d square. And you know within yourself that d is x minus min. That is all. Do you get that now? Okay. Yes. If you put d, then you have to put this to show the examiner that you know what you're doing. That it stands for x minus min. But if it is just x minus min you're writing, you don't need to put d again. Do you get that now? For variance is the square of this summation f into this thing that is inside here. Is variance without this square. Yeah, that is summation f d square over summation f, or summation f x minus min square over summation f. That's the variance. You get that now? Exactly. It's going to cancel the square root. Okay, so moving on, if we are through with this and if there's no question, we move on to the second question, second calculation we have in this 2013. Okay, so I can start this wrapping up our way. Okay, okay. This is the formula for variance. Yes. So if you have gotten your standard deviation, just put a square on it, square your answer. That is 18.4 square. Not 18.4 square, not the square root of it, though. The power of 2 of that answer. That's the variance. No, square root is different. Square root is this. Square is this. The power, raised to the power of 2.
Hello, please, can I talk? Hello.
Yes, you can talk, please.
I wanted to take note of something. The lecturer said we should always end our answer in 2 decimal places.
Okay,
so take note of
it. Okay, yes. So I'll just give you a note now that we are supposed to end our answer in 2 decimal places. But then this is my answer in 2 decimal places.
Okay.
This
Now
is
I'm
the answer
just
because,
bringing your.
yeah, thank you very much. Because this is 96. This was made, and the child was made this. I will look at the number, which is right, and this is number 5. I didn't marry him. That's that is that's two decimal places. I hope that they said man said to leave our answers in 2 decimal places. You get that? But in the calculation, we talk with 3 decimal places. Like decimal place with 3 numbers after decimal point. You get now 2 decimal places mean 2 numbers after decimal. So the way this is now, this is 2 decimal places, 2 decimal places, 3 decimal places. Do you get that? So if you get your answer, don't stop there. Continue until you get 2 numbers after it, and that's done by approximation. Do you get that now? Any other question?
Hello. Please, this standard deviation for variance, you said we should square it. Can we just, from looking at it, is the variance not 338.40?
Yes.
Hello?
It's 338.
The minus 1.
338.
In Anova. Wait, calm down. In Anova, there is standard deviation underneath it. I calculated it using minus 1. You know, you put the answers there. I did not get the answer with minus 1 until I used this normal one. That's when I got the answer. That's why I said, let me put this one. In the textbook. So you put minus 1 in the class, Abi. You put minus 1. I hope we'll follow is minus 1 then. But me, right from time, I've always known standard deviation to be
Hello, Mayowa.
Yes,
Hello, Mayowa.
Yes, I'm listening.
Mayowa, can you hear me?
Yes, I can hear you.
Please, for looking at this, what you solved, I can say my variance is 338.40.
Yes, that is it.
Okay.
All right, please, now move on. Notes, please. Notes. In the textbook, and according to what the man taught in class, he said our standard deviation here to carry minus 1. Do you get that now? Minus 1 here. Although the reason why I stuck with this summation F is because after I solved the Anova he gave in class in his textbook, I used that minus 1 to also try to get the answer there. I didn't get it until I used this one. That was when I got the standard deviation. But they said in the class, he said we should use whatever it says, and that's minus 1. So I think we have to put minus 1 here too. Man is kind of efficient. You said?
No, I don't
instead
think
of
so.
summation F, it's going to be summation F minus 1, and that will be 1 minus 1, and that's going to be about 50. You get that now?
Hey.
You're not going to get the same answer because it's going to be close to it.
Maiwa, please, I didn't understand though. Minus 1 where?
Minus 1 where?
Minus 1 under the summation F. I hope it is clear.
No, why are you putting minus 1?
Are we going to include it in the formula while solving?
Yes, in the formula, yes. No, the mean. This is the formula for me. This is the formula. It doesn't affect the mean. It's only the variance. I mean, standard deviation, yes. Summation F minus 1. Yeah, that's the same formula for variance. The same thing, yes. Okay, can we move on? The page. That's page 104. Okay, can we move on? 104. Now we are not testing for any relationship or anything, so we don't need to go to the back of the book to go and start looking for any physical value or whatever. He only said find the mean, standard deviation, and whatever, and we are through with that. So let's go on with the next one, still under this 2012, 2013. We can see a question there on that question. I don't know, looks like question 3 or 4. It says below are the scores of 15 students in statistics and biology. And we are given a table there. One for statistics, another one for biology. We have the raw data there. It says, is there a significant relationship between the students' performance in statistics and biology? 60 square, 47 square, 44 square, 45 square, 51 square. So we just need to find summation of Fn. So let's start. Let's find our summation xy. We have to be careful with the numbers. So.
Hello, Mr. Mayo. Why can't we find summation of x and summation of y?
Yes, that's what we are doing. Summation xy.
I mean, summation of x
and
summation of y.
Everything.
Okay, okay.
Yeah, it's part of the formula. We'll do everything. We are summing everything though. The x, the y, this. Okay, how about y? Y is 737. Okay, xy now. 408. 408. Okay. How about x squared? 44056. And then the y squared. 3. All right, so with this, we are through with our table. We just impute all these things into the formula. Let me record the formula again. That's our rank xy equals n summation xy minus summation x summation y over square root of n summation x square minus summation x square, then multiply by n summation y square minus summation y square. You can see it easy. N summation x, n summation xy minus summation x summation y over whatever you do for x in this place, you do it for y in this place. So just remember what you do in this place and leave this one. You know you multiply this. You said? Okay, it's not. So that's n summation xy minus summation x summation y over square root of everything of n summation s square minus summation x all square, close the bracket, multiplied by n summation y square minus summation y all square. What is it now?
Easy.
Yes,
Easy. Why or why easy?
That's a difference. This is summation x square. It's only the x square. It's only the x that is carrying square. That is this s square. That's what they are talking about in this place. But this one is summation x, this one, that you are going to square at the end of the day. Do you understand English? You don't understand. This summation x square, you will come to x square. This is x square. Where is the summation? This is it. This is summation x all square. So where is summation x? This is summation x. Then you now square it. So that's different. This is what I said, though. This is what I said. Yes. N is the number of values you have here. So in case you don't want to get confused, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So your N is 15. I hope we are getting it. So from here, I believe we can even get our answers ourselves. Can we do that? Yes. That's 37965. You're right. very, very careful with numbers. But fine. All right, I think we started solving it, right? All right, so we have R, this blah, blah, blah. N is 15. I believe we all know we got 15. That's 15 multiplied by summation xy, which is this one, the addition of this rubbish. Multiplied by 40846. You get that right? Minus summation x. This is summation x. 794, but I'm putting in brackets because it's still going to multiply another digit there, which is summation y, and that's 737. The reason why I'm putting it in brackets is to show that this minus belongs to both of them. You get that now? Divided by the square root of n, which is 15, multiplied by summation of x squared. You can see there's no bracket there. And this is summation of x squared. 44056 minus summation x, which is 794 squared, right? All this is going to multiply and multiply by summation y squared, which is 37965 minus summation y, which is 737 squared. And this is what we are solving. Not to make mistake, you can take your solving one after the other. Do this, come under, do this, come back again, subtract them, do whatever you have to do downstairs, do the square root, and then divide them finally, and you're through. All right? So if we should do this first one now, we are going to have our value to be 15 multiplied by. Serious, so there's naira lẹ́yìn àbí dollar. 612,690 minus 585,178 divided by the square root of, let's do this, 15 times 44056. That's 660. 840 minus 794 square. 630,436. Then multiply by this also. 569,475 minus 543,169. I hope we are getting it. Are we still following, please? So now I'm going to subtract this. All these steps in mathematics, the mathematician will tell you that they all carry marks. So they're all important. Don't skip anyone. In fact, in mathematics, it is the steps that are marked. What do you want to say? Yes, sir. Steps go matter. The final answer may just be 1 mark. So it's the steps that matter. What to do. You understand now? That English. Yes, now it will be 1-1. Yeah. Yes, sir. Yes. Yes. That's still 737 square. Is it in there? Square. Yes. Yes, that's what I was explaining to her. That this summation y square, it is only the y that is carrying square. And where is the y carrying square? This is it. That's why we did the summation here. Do you get that now? But for this one in a bracket, it is both summation and y that are having that square. So you will look for the ordinary y. This is it. 7 to then square it. Do you get it now? That's just different between them.
But
That's why when I'm saying it, I'm always saying all square. All square. N summation s square minus summation x all square. Do you get that now? Bracket N summation y square minus summation y all square. Yeah, it's only y.
Hello,
Not the
hello,
summation
Mr.
of the
Mayowa.
square of it. Yes, I'm listening to you.
Hello, Mr. Mayowa.
Yes, I can hear you. Please.
But according to our textbook, in page 134, what is written there is bracket summation x squared bracket.
Bracket what?
Bracket summation x squared, then close bracket.
And that's what I did now.
Is there a mistake or what?
It's not a mistake, it's the same.
But it's not the same formula that he applied when solving the question. Look at page 135.
It's the same, trust me, it's the same. It's the same. There's a bracket there. You see, in your textbook, you have bracket in the denominator. You have square roots, open a bracket, and summation x squared minus summation x all squared, then close the bracket, right? Right? Then it didn't open another bracket.
The formula that he gave us, squared, is inside the bracket, while the one that he used when solving the question, squared is outside.
I didn't get what you said. Please say it again. I didn't get what you said. Please say it again.
Look at the formula that he gave in page 134.
I'm looking at it.
The square there is within the bracket.
Yes, now in my own too, the square is inside the bracket.
In page 135, the square is outside the bracket.
Hello, Mrs. Otuba. I noticed this.
I'm not getting what you're saying.
On number 135. Use the one on page 135. The one you're talking about.
Thank you very much. Use the one on page 135, please.
Use the one on page 135.
That's what I'm saying, because the two formulas are not the same.
No, use one on 135.
Okay.
Step by step.
All right, well understood.
You made me. You know you still find the square root, You know there's a square root in the denominator. Don't forget though. No, you just do square root. No. You just do square root. Answer. Then give you, if it's correct. I think this is the subtraction bar over. Let's do this also. Please, what's the answer? I want to subtract this. You have gotten it wrong. Yeah, we're doing it step by step. Yeah, let's do step by step, please. In fact, step by step is better because you get your mark for it. 2 marks. 3 kini. Okay. Then the next thing I'm going to have 27512 over the square root of, now just multiply these two. Okay, should be correct. Just multiply these two values together. 799 807, right? I hope I'm here. 624. Yeah? So for me, I'm going to have 27512 divided by, now do the square root of this answer. 28. Yeah, it doesn't matter. 0 at the back of decimal doesn't matter. Except it's at the middle. So can I clean this table, please? Okay. Okay, let me. No, it's not going to appear in this sense. This from this place, it's only appear in there. Okay, let me just manage this place. So let's divide this. Our RXY then is going to, let's divide this. 973. Remember I said we should give our answer in 2 decimal places, Abi? So that's 0.97. Now, but this is not our final answer. Remember, this one we are trying to check for a significant relationship. Aha. Right? Are we ready? Or should I wait for you to get to this place? Because we need to go to the back of our textbook. I hope we all have our textbook. Do we all have our textbook? Okay, if we all have our textbook now, let's go. Now, the next now is to find our degree of freedom We've gotten our calculated value. Let me write it out. We need degree. Can I shorten it because of the board? Degree of freedom. And degree of freedom is gotten with the formula what? N minus 2, is it not? Now, next, we need to find our critical R. For Pearson, it is critical R because if you go to the back of your textbook, you are going to see T, R, and I think there's F too, and there's Z subscript R. But for Pearson, we are working with Pearson. The table you are going to check is the one carrying R, critical R. So let's go to the back of our book. DOF is degree of freedom. Okay, please, let's be fast so I will make it bigger. Just hold on, I will make it bigger so everybody will understand. Have you seen it? Yes, okay, critical values of the present product. That's what we are checking.
Okay. Please, what page is the critical value?
That one is, just go to the back of your book. From that beginning, the second one, the second table there is what we are looking at. That's table C. Table C. Table C.
Okay, critical values of the Pearson products.
Yes, critical values of the Pearson product because we are working with Pearson. Yes.
Okay.
Can I clean the table? Now, like I said, unlike that first question we treated, where we are just asked to find the mean, median, and mean, standard deviation, and the variance, this one is actually asking us to It's asking us to check if there's a significant relationship, right, between statistics and what? Biology. So I'm not just going to stop on this, my answer, at 0.97. This 0.97 we've gotten now is what we call the calculated value of R. Is it not? Now, for me to get the critical value, there are some times in his past questions, it gives the value itself. Other times, it doesn't give it. But I think he said he's going to give us these tables separately. So that means it might not give us. So let's learn how to get it now. So our calculated value is that answer we've gotten. The next thing we need to find out is the degree of freedom.
Okay.
Now, how do we get our degree of freedom? For Pearson, it is simply n minus 2, where n is what we got the other time, the total number of
15.
values you have there. We got 15 minus 2, and that is what? 10. Right? And the next thing now is to get critical value, because it is this critical value that will tell us whether to retain the null hypothesis or to retain the what? The researcher's hypothesis. I believe you know the rule behind that one now. Okay, when we get there, we'll do that. Now, for my degree of freedom, which is 13, now I'll go to the critical values of the Pearson product moment correlation coefficient. Just that second one you have there, the second table you have there. Now, it is with this value I have here, I'm going to check. Remember, you have to test with 0.05, right? So, and if you look at the table, remember, and in class, I remember I said it is this one, this non-directional, we have to make it up. This second value, not this one on top. You are always making use of the non-directional two-tailed values there. Do you get? So for me to get 0.05, this first value here is 0.10. This second one is 0.05. This third one is 0.02, 0.01, 0.001. But what I need is 0.05. So what I need is this second column. Is it column? Is it column here? Third column, actually. Do you get that now? Now, this is 0.75, right? Which of these values am I going to pick? How do I get that? This is where your critical value is needed. What is the value for my degree of freedom? Sorry, 13, right? So I'll go to this first column and look for 13. Where is 13? This is 13, right? Then I will trace it to the what? 0.05 point. The value there becomes my critical what? Value. I hope that is clear. So what's the critical value we have here?
0.5139.
5139. Abi?
Yes.
I should repeat, okay? Now, where did you get lost actually? Now, what is your n? N is the total number of values or variables you are dealing with, which is 15. And so my answer here will be 15 minus 2, which is 13. It is with this value now you are going to get your critical value. How do you get it? Go to the table you have been given. Make sure it is under Pearson because we are working with Pearson here. So now after you've gotten that, you are asked to test from the question. It says you should test with 0.05 level of significance. If it is 0.01, it's another one you are going to look at. Just go to the back, the second one after these formulas. I think if you count it, that should be page 177. Table C. Not that one. Keep flipping it to the right. Flip it to the right. Have you gotten it? He said? Yes, let's everybody get it so that we'll go more. Have you seen it? All right. Now, remember we have to test with 0.05. You are always using the non-directional two-tailed tails. This one underneath. So for me to find 0.05, this is it here, this third column here. Right? Now, what's the value for my degree of freedom? 13, right? So I'm just going to look for 13 under, it's even written. Degree of freedom equals n minus 2. So you look for 13 under this column, this first column here. This is 13. You then trace it to the point where it touches the 0.05. The value you have there becomes your critical value. You said table C, table C. Table C is what we are using for Pearson. I hope this is clear now. Now, if I look at this thing now, you will see that our 0.97, our calculated value of R, is it bigger or smaller than the critical value? It is bigger than it. Therefore, what will be the hypothesis we are going to retain? We are going to retain the Satchers hypothesis and discard null hypothesis. I hope you get that. So now, okay, when your calculated value is bigger the critical value, you always retain the research hypothesis and discard the null hypothesis. Do you get that now? But if your critical value is bigger than it or equal to it, you are going to retain the null hypothesis and discard the research hypothesis. So this is how you are going to write it according to the textbook. It says from the analysis, and then under this also you put level of significance is 0.05. So to formulate it and put it in words, because you're not going to stop here, it says you're going to write it as this. From the analysis, the calculated value was 0.97 as the relationship between student performance and statistics. Now, are you writing? Yes. Okay, let me tell you. Yeah, it's from a test. I just formulated it from relating it to the question solved. Yes. Yeah, from the analysis, the calculated value was 0.96. I'll be 97. 0.97. It says the researcher was interested in determining whether residential location has impacts on the performance of students in statistics. Then he obtained the following data from SS students in urban school and those from rural school. So under this now, we have the rural and we have the urban. Rural is given as, the urban. Values we have here. We have n to the equals to 168. Of fx equals 9461.76. S equals 4.18. And then for rural, we have n to the equals to 182. Summation of fx equals to 9789.78. And SD equals 3.88. So basically, since you already recognize that you are making use of student test there, what you just need to do is to record the formula for student test. So what's the formula for student test? Formula now. Okay, is that the first thing? All right, this one says we should formulate and test appropriate hypothesis at 0.05 level. Is very simple. To formulate is very simple. It's from the question you are given, you are going to formulate. And what you are going to formulate is going to contain both the null hypothesis and your own hypothesis as the researcher. You get that now? Your own the null hypothesis is that there is no relationship. You have to follow what is written here, the English that is used. Use it for the man too. What I'm just trying to explain is that the null hypothesis is just trying to tell you that there is no something you are looking for. Why your own hypothesis is the question itself. Do you get that now? So if I'm going to formulate the hypothesis here, I'm going to have H1, which is the researcher's hypothesis. H1 is the researcher's hypothesis, while H0 is the null hypothesis. That's the question. It says we should first formulate. So now let's formulate. The question says the researcher was interested in determining whether a national location has impact on the performance of certain statistics, right? So what will be the researcher's hypothesis? It's simply going to be there is significant impact of residential location on the performance of students in statistics. Yes. From his textbook, I'm not sure he's always putting the population, but let me recheck just to be sure. The population. So it has to be there. There is significant impact of residential location on the performance of students in statistics of SS2 students, in rural and urban areas. Okay, since there's a total location there. Then our H0 is simply going to be the opposite of this. There is no. And you know it's English now. English, now. English is English now. So there's letters here, right? All right. Then for your null hypothesis, it's simply going to be there is no. Then you finish up with the remaining. I believe that is clear now. While you are writing, let me quickly copy out the formula. So just continue from there. So we are on student test, and I've explained when to use it, right? I believe you understand when and when not to use it, right? And this is formula. First, we're asked to formulate the hypothesis. We are going to come into first the researcher's hypothesis and the null hypothesis. Yes, I said you use this particular test when you are getting your samples from two different, you are getting your variables from two different samples. Do you get that? That's the basic condition for you to use this thing. When you have two variations and you need to get samples from them, that's when you make use of it. Moreover, there must be impact or influence of something. Do you get that now? So, for instance, in this question, there is the impact of residential location. Do you get it now? On the performance of students. And we're having two samples. We have the rural location, the urban location, and the what? The rural location. That's why we are making use of the student test for this question. I hope that is clear, right? Okay, and then we recall the formula. The formula for that is the mean one. Remember, by X means mean. X bar or by X, whichever one. Means the mean. This is X1. X1, we could use our urban to stand for the ones carrying the ones, and this one should be the ones carrying the twos. So X1 should be the mean for the urban minus the mean of the rural divided by the number, the total number of variables or those you collected your data from, minus 1 into the standard deviation square plus same thing, n2 minus 1 into the standard deviation square divided by n1 plus n2 minus 2 into 1 plus n1 over n1 plus 1 over n2. Note, this square root is covering everything. Both this and this. That square root is covering everything. I hope that is clear, right? So then we now go ahead and impute all these things into the formula, and that is all. That's why this one is quite simple. What we just need to know is when to use it and also to know the formula. That is all. Now, but for me to apply, that is to impute these parameters into this my equation, I first need to find the mean. Because as you can see in this thing we're given, we're not given the mean. We're only given the number of variables, that is those you collected data from. You are given the summation of everything, including the summation of fx. And you are also given the standard deviation. So the first thing you are going to do is to find your mean. Do you get that now? So let's find our mean. Mean is, we recall the formula, summation of fx over summation of f. Is it not? What's our summation of fx for 1? Remember I said urban should be for the 1 and rural should be for the 2. So our summation of fx in this case is 9461.76 divided by summation f, which is the n, and that's what? 168. So our mean for the urban area is going to be what? 9461, is that? So we have 56.32 in this case. We do the same thing for our rural because it is also needed. Mean 2. So our mean 2, that is x bar 2, because the same formula. Summation of fx over summation of f. And that will be 9789.78 divided by 182. So what do we have there? 53.79. So with these two answers now, we can go ahead with our solution. I think I can clean this part, right? This my hypothesis. Can I clean it? Okay. Now, imputing these two things into the formula, I'm going to have our t to be equals to mean 1. Mean 1 is 56.32 minus mean 2, that's 53.79, divided by the square root of n1. What's our n1? That's 168 minus 1. Then the square of the standard deviation, which you have been given as 4.18 square, remember, plus n2, which is what? 182 minus 1 multiplied by the standard deviation, which is 3.88 square, right? All divided by n1 plus n2. That's 168 plus 182 minus 2. Remember, all these are inside a particular bracket. And it's going also to multiply 1 over 168 plus 1 over 182. Remember, this square root is covering everybody. I hope this is clear. I only imputed those values into the formula. That's what I did. So now let's calculate. T now becomes, let's calculate our numerator. 56.32 minus 53.79. That's 2.53 divided by, now let's solve this. Let's solve the numerator of this denominator first. Then we solve the numerator with it. And we also solve this. So 168 minus 1 is what? 168 minus 1 is what? 167. Should we do it step by step or should we just move on? we'll take this one, we'll take this, and take this, right? Okay. So 168 minus 1 is 167. So 167 multiplied by 4.18 squared is going to give us what? 167. Okay, that's 2917. Remember, we are still working, so you have to leave it in 3 decimal places. So that's 891, is it not? Plus, let's also solve this. This will be 181 multiplied by 3.88 squared. 2724.846 divided by, let's solve the numerator, 168 plus 182, that's 350 minus 2, that's 348, right? All this multiplied by, let's solve this, 1 over 168 plus 1 over 182, that's 25 over 2184. I hope you are getting it. I hope we are getting it. Okay. Which one? Yeah, I use my calculator. This, you can write as decimal. You can write as decimal. No, it's just the calculator. Instead of using this division, I use this division instead. That is 1 over 168 plus 1 over 182. That's what gave me 25 over 2184. Now, he said, okay. That's AO number B over C in the calculator. Yes. Yeah, it's in every calculator. But we are still going to leave it in decimal. The reason why I left it in fraction is because this one is also still in fraction. Do you get it now? Once I put this in decimal, I will also put this in decimal, and then I can finish up my work. Can I clean this side? Thank you. So from here now, let's solve this one. I'm going to have T. T will be equals to 2.53 divided by, now let's add this. That's 2917.891 plus 2724. Yes. 0.824. No, it's 0.891. Is 891? Yes, 4.1 is multiplied by 167. Remember, it is. Maybe this is it. You made mistake now. Okay, you first did 4.1 square. That's 17.474 multiplied by 167. It's still the same thing answer I got. No, you made mistake. See, 472 is what you wrote. And see, 4.18 square is 472. That's it. I don't know what you're doing now. Can we move on? All right. So to continue now, let's solve this numerator. I'm going to have 2917.891 plus 2724.846. That will give us 5642.737 divided by 348. then multiplied by 25 over 2184. So now I can put it in decimal and finish up my work. T becomes 2.53 over root of, that's 16.215 multiplied by 0.011. So T will be equal to 2.53 root of 0.186. That's, we have 5.87. The remaining, what I did there is just simple pressing of calculator. Yes. I know. On the board, it's giving me what? Yeah, I know. The reason why I did so is because while pressing my own calculator, I only wrote it as 3 decimal places here, but I used the full number to multiply. Do you get that? Use 3 decimal places. I know, I didn't want to. I was just moving fast. That's 0.011 multiplied by 16.215. That's 0.178, Abi. So let's use that. Which one is not making sense? It's multiplication. Look at it. 25 divided by 2184 is going to give you 0 point. You said? Yeah. For the final answer. Okay, let me start again so that we all get it. I'm going to use 3 decimal places throughout. Yes. This. Yes. I should. Yes. Okay. 1 over nothing. It's just normal pressing. 1 over 168 plus 1 over 182 equals to this. So if you want to put it in decimal, press this again. That's all. Is that A O number B over C? All right, can we move? You know what? Not to cause confusion. Let me leave my work in 3 decimal places. So I have 5642 divided 0.737 divided by 348. I think that gives us 16.215, right? Is that the same as yours? Is it the same as yours? Please check. The division of this. Then 25 divided by this is going to be 0.011. Is it the same? Okay. So we have our t to be equal to 2.53 divided by root of, then we'll multiply. That's 0.178. Is it not? I think it's what you got, right? Then t becomes 2.53. Find the root of this now. And that's 0.422. Abi? So we then divide. And that's 5.995. Abi? Is that what you got? You said? That's approximately 6. Do you get it or you lost? What's the problem? Any other problem? Do we understand how we got this? Okay, now let's move on. Now, just like the way we did it in Pearson the other time, this is not our final answer. Okay, have we been given the critical value? Okay, we've been given the critical value as 1.96, is it not? So from there, who can tell me our final answer from there? Like, so from here, our calculated value degree of freedom is n minus 2, Abi? And that will be what? 168 plus 182 minus 2. 168 plus 182 is what? 350, is it not? And our critical value is 1.96. I think that is all. So from here, what will be our final conclusion or decision? Who can formulate the final decision from where we have? And remember, you have two n's, this and this. So you use the total n, this plus this, then subtract it from 2 to get the degree of freedom. And which, okay, no. It's going to be 1 n, 1 degree of freedom, which is the addition of these two. You get that now? Yeah, the calculated value, I wrote calculated value, yeah. It's greater than the critical value, right? So what then will be our decision? Yes. Yes. Significance we are testing is 0.05. Yeah. Oh, yeah, finish it now. So what are you going to oppose? You will, okay, I've finished. You will oppose the what? The researcher's hypothesis. That's what? There is significant relationship between the impact of what is it called? Residential location on performance of students in statistics. And that is all. You get? Okay, I'm going to, let me repeat it the way it's written here. Okay. Are we ready? Yeah, it's the final answer is supposed to be in 2 decimal places. Do you get it? So when I approximate this, it's going to be 99, and this one will be 00 exactly. The reason why I didn't check the table is because in the question we have been given, it's going to be table. Yeah, of course. That one that has T. Yeah, critical values of T. Yeah, that first one. No, that 0.05 is another one entirely. This 0.05 is what the question says we should test it at. It says we should test at significance level, significance level, yes, at 0.05. Yes. I hope this is clear. Okay, yeah, let me dictate the statement there. It says the calculated T value, the statement, the final decision that is going to be there. The calculated T value was 5.995. Yes, it's not infinite. That's why it is 1.96. Was 5.995 as the residential location influence the calculated T value the calculated t-value was 5.995 as the residential location influence, on the performance of students in STAT. Or the performance, okay, since we have to put the population, so we should put of SS2 students in STAT. Do you get? All right. In STAT, statistics now. Full stop. This and now we are dealing with statistics now in urban and rural places now. Do you get? Full stop. This calculated t-value is significant. This calculated t-value is significant since it is greater than the critical t-value, of 1.96. Given 348 degrees of freedom, at 0.05 level of significance. Or at 0.05 level of significance. Full stop. This led to the upholding of the researcher's hypothesis. That residential location this led to the upholding of the researcher's hypothesis. Yes, the residential location has impact on the performance of students in statistics. Do you get that? All right, so that's about. However, I would like us to look at the 2017-2018 question. It's still on that test, but with a difference of something there. What is the difference there is that if you look at the, do you have 2017-2018? Yes, the question 4. Please look at 2017-2018. So if you look at that question, very sorry. The question 4 says the researcher was interested in determining whether student perception of their teacher influences their statistics performance. Then he categorized the students according to their perception of their teacher and obtained the following results. So this one, we have the sample of the positive, and we also have those under what? The negative. But if you look at it properly, I think it has been sent back. You will see that it's not given in this kind of data that we have here. It has not yet been solved. So that's where you need the idea of how to get standard deviation and your mean. Do you get it now? And thank God we've done it today. So the first thing you're going to do in this kind of question to have your cumulative frequency table. Do you get it now? From your cumulative frequency table, you then get your mean and your standard deviation before you now apply this formula to get your answer. Question 4 of 2017-2018. It has been sent to the group. All right, so we'll move on to Anova, right? That's analysis. You said? You are going to create, what is it called? Class interval for it. You get and note, remember what I told you that time? Class interval, the number of class interval must always start from 5 to 10. If it is lesser than 5, you have to reduce the width of the class. Do you get that now? Until it is more than 8, then you can make it. So for instance, now, the smallest number here is, okay, the smallest is 20, Abi. So if the smallest here is 20, if I say I want to use 20 to 30, first, let me look at the highest number. The highest number is what? Okay, 55. So you see 20 to 30, 31 to 40, 41 to 50, 51, is that not 4? So you see that is not enough. So you have to reduce the class width. Do you get ahead? So it will be 5 numbers. So that's 20 to 24, 25 to 30, 31 to 34, blah, blah, blah.
Hello, Mayowa.
Do for positive and you also do for negative separately. You derive out these 2 points from it before you now start working. Which n? N is your summation F. The total of the 2 points is your n. Let's move on to Anova, the analysis of variance. Now, when do you make use of analysis of variance? Analysis of variance is simply when your samples are more than 2. Do you get that now? When your samples, you are testing for the influence of something on a particular relationship, exactly like that one. Once they are more than 2, then you are going with Anova, the analysis of variance. When your samples are more than 2, you make use of the analysis of variance. Aha. So basically, when they look like this, when you please what pass? Okay, when they look like this, can you see Anova straight? When they look like this, student t-test straight. When it is just significant relationship, there's no influence, Spearman or Pearson. So you see that it's easy to understand. You count the formula. Yes. All right, so let's move on. Let's see question 3 of 2017-2018. Says a researcher was interested in examining whether counseling affects performance of students. 2017-2018. Question 3. So the question says that a researcher, please, are you listening? A researcher was interested in examining whether counseling affects performance of students. You don't have it. And look at 2018-2019, it's the same. The number 4 of 2018-2019 is the same. And depends on the performance of students. The group students into 3 groups and use, you understand English there now, treatment. That is control on the first group, groups counseling on the second group, while the third group were exposed to individual counseling. After 8 weeks, the post-test results were as follows. Group 1, we have a set of numbers there, same as group 2 and same as group 3. We are asked to formulate our hypothesis and test the data at 0.05 level of significance using the critical value of 3.88. So who can formulate an appropriate hypothesis for us? Who can help us formulate an hypothesis for this question? Okay, that's H1, Abi. So the first one is there is significant effect of counseling on the performance of students. Okay, and then the second one, there is no significant effect. I believe we have that. All right, so now let's start. Since this is Anova, I can clean the board now. Now, one thing I really don't seem to understand in this one is that in his textbook, he found the standard deviation at the end of the table. But after going through the whole solution, I realized that there's no way we'll make use of the standard deviation. So the thing is, I don't know, maybe we should also find the standard deviation and put it the way he did it inside the textbook, or we should just move on. We have to find it, right? Standard deviation now, normal. All right, so for this one, we have group 1, group 2, group 3. All right, we have group 1, group 2, group 3, right? So we can represent them with A, B, C, or X1, X2, X3. Any one of your choice. You use X1, X2, X3, although in his textbook, it's always using A, B, C. Okay. So we use A. A should be for the, what's the first test there? Traditionally. Control. Okay, so our A is control. So we have A and so what are the values for A we have there? 23, 33, 36, Abby. Now, after our A, we are going to find the square of A. Same thing for B. We'll find the square of B. And C, we'll also find the square of C. And that's all for the table, I think. Yes, just A square, B square, C square, and that is all. So let's find our A square. We all can find A square, right? That's 23 square. 23 square is what? 9 is 1. No. 5 to 9. 33 square. 36 square. 38 square. 33 square again. And 35 square. So let's move on to B, which is the traditional B. Group cancelling. So what are these values here, please? 31, 38, 37, 42, 38, 36. We also find the B square. Okay. I thought it's 4, 4, 5. So 4, 4. 1, 3, 6, 9. 42 square. 38 square. And 36 square. All right. So we'll go to the last group. You said, and it doesn't matter because this is now A square, B square, C square, straight up. So for our C, please, what are the values there? Values there, 35. 40, Abby. Then we have C square, right? 1, 2, 2, 5. 1, 6. Okay, 1, 6, 0, 0. 1, 8. All right. So our table is complete. So we'll find the summation of everything now. So this is summation X, Abby, because of our formula. Summation X1. What's the summation? So let's do summation S square now. Summation of this. 2, 2, 2. Then summation X2. H2. Koyemi. 2, 4, 4. All right. This is clear, right? So the next thing is just to apply our formula. Now, basically, there are 3 things to find in your formula. You need to find the sum of squares between the group, the degree of freedom between the group, and the last one, the mean of square between the group. Then you also find for within the group, the sum of square within the group, degree of freedom within the group, and then the mean of square within the group. That is all. So basically what I'm saying is we are looking for MSB, SSB, DFB, MSB. Then thereafter you find SSW, DFW, and MSW. So you use it to find your F ratio, which will be MSW Is it this over this or this over this? So basically, this is what we want to look for. Do you get that? Sum of square between the group. It is also known as fitment. Sum of square between the group, degree of freedom between the group, mean of square between the group, sum of square within the group, degree of freedom within the group, mean of square within the group, and the Fisher's ratio, which is MSB over the MS. That is the answer here divided by the answer here. You said? F ratio. That's Fisher's ratio. The Fisher's ratio. F ratio. In the textbook, it is F ratio, but in the class, I think we called it F test. But in the textbook, it's F ratio. But the reason why I'm going with F ratio is because it's actually a ratio. This over this. Exactly, you understand. You understand. So now let's bring out the formula for SSB. The formula for SSB is summation x1. Is there no square there? Summation x1 square, Abi, plus summation x2 square over n2 plus summation x3 square over n3. Which one? N2. Is it clear now? Minus summation x1 plus summation x2 plus summation x3 all square divided by capital letter N. Now this capital letter N is N1 plus N2 plus N3. Yes. Do you get that? That is how do you find your capital letter N. No, so that you will understand how we got the capital letter N. N is equal to N. You just sum all these together. That is the summation of the small letters. We'll give you the capital letter. All right, so now let's move on. From here, our SSB will be equal to summation of x1, which is what? 198 square over n1, which is what? 6. How did we get 6? 1, 2, 3, 4, 5, 6. Do you get that? Over 6 plus summation x2, which is what? 222 square over n2. n2 is also 6. 1, 2, 3, 4, 5, 6. Over 6 plus summation x3, which is 244 square over 6 also, because it is also 6 in number. Minus summation x1, which is 198 plus 222 plus 244 all square divided by 18. I believe we all know we got 18. 6 plus 6 plus 6, which is 18. I hope we are getting it. All right, so from here now, since we are solving step by step, let's solve this. So our SSB will be equals to 198 squared divided by 6. I believe we all understand, Abi. Plus 222 squared divided by 6. S214. Plus 244 squared divided by 6. Minus, let's do this, 198 plus 222 plus 244. Then square it and divide it by 18. Is that the final answer? Two, 4, 4. Right? So let's sum these three together and then subtract it from that. Final answer. 17. I hope this is clear. No, so when you are solving it personally in the exam, you should split the steps. All right, now that we've gotten our SSB, the next thing to find now, this one is out of it already, right? Yes. I gave you. Yes, it's because this one is splitted into 6 things that you need to find. Exactly. This is SSB. This is the formula for it. DFB has its own. MSB has its own. SSW, its own is every one of them. They all have individual formulas. No. But your table is just going to contain this thing. A squared, B squared, C squared. That is all. Exactly. Uh-huh. All right, now that we've gotten our SSB, now we'll move on to DFB. The degree of freedom between the group. And now it's simply gotten by what? K minus, is it minus 1 or 2? K minus 1. Now, what is K? K is simply the number of groups. Do you get that now? And in this case, we are dealing with 3 groups. Group A, Group 2, and Group C. Right? So we have 3 groups. Therefore, the degree of freedom between the group is going to be 3 minus 1, which is what? 2. That is also out of it. Right? Now let's go to MSB. What is MSB? This is the mean of square between the groups. That's when we'll consider this squares. Right? So let's find our MSB. This is what the formula for MSB again. SSB over DFB. And that will give us what? Divided by 2, is it not? And that will give us what? Okay, this is nice. I will still make use of this. So now that we have gotten these 3 things, let's go to this next one now, SSW, where we will consider these squares. Right? Which one will I clean now? Can I clean the top part of this? Because it's just this answer I need from this table. Can I clean the top part? All right. So just like what we did for between the groups, we will also do the same thing for within the groups. So what's the formula for within the groups? Yeah, let me split it. I think it is summation x1 square plus summation x2 square plus summation x3 square minus summation x1 plus summation x2 plus summation x3 over n square. All right. So our SSW now becomes what summation x1 square? That's 6672 plus summation of x2 square 8278 plus summation of x3 square 9972. Is it not? Minus summation of x1 198 plus 222 plus 244 all square divided by n. N is what? 18. Is it not? I hope we are still following. Okay. So our SSW, please let's add this together. 6072 plus 8278 that's 24922, right? Minus, solve that also. Okay, 24494. Okay, yeah. 24494.222. So our sum blah 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 within the groups. Those 4778, right? Also for this, you can see we've solved this, right? So we'll go to DFW now. DFW is simply n minus k. Unlike that one, this one is k minus 1. For within the group, it is n minus k. Your n is the 18, while your k still remains the number of groups. So in this case, it's going to be 18 minus 3 to give us 15. Do you get that? Now we then solve the MSW. The MSW is simply SSW over DFW. And that will give us 427.778 divided by the DFW, which is what? 15. So what do we have there? $28,519, right? So from here now, we are done with our work. We just find the Fisher's test or ratio, whatever. I think he gave test in the class. Let me put it this way. And that's given us MSB over MSW. Remember, we got our MSB as 88.223 divided by the MSW, which is 28.519. What's the answer to this? 3.091. But remember, this is the final answer. So that will be 3.09. Is it not? Now, from here, okay, let me hold on. Are we through? All right, so from here now, like you said in class, you don't stop here and say you're through with your work. After doing this under Anova, you then have something like an analysis table, where you are going to impute everything you've gotten so far. So your table is going to contain the sources of variation, it's going to have the sum of squares, it's going to have degrees of freedom, yeah, this is the continuation of the question. You don't, this is the answer, but you don't stop there. I think we've been given the critical value, right? So we don't need to look for it. But in case you are not given the critical value, do you know how to get the critical value if you are not given? That I know. Okay, if you are not given the critical value, it is with your degree of freedom you will get it. Remember, we got 2 degrees of freedom. The first one was 2, the second one was 15, right? You are going to make use of both. So let's go to the back. Just in case you are not given, but I believe it's going to give us. So you will see table E, critical values of F. It is Anova that is carrying F. You said? Yes, Anova is F, critical values of F. That's table E. Have you seen it? Table E. Now, for us to get our, Now, for us to get our critical value, like I said, we have 2 answers there, right? 2 and 15. Now, these top values you are looking at, you can see for each numbers, you have two numbers attached to them, right? For 0.05 level of significance, you look at the top one. Is it the top one? Yes, the top one. For 0.01 level of significance, you look at the one under. But it's not always talking about 0.01. It's always just 0.05. So we are concerned with the values at the top. How then do I get my answer? 2 and 15. These 2, am I too slow? Table E, critical values of F. With what? Let me. Are we ready? Table E. Table E of F, yes. Can we move? All right, now, these 2 you are looking at represent the horizontal, yes. While the 15 is those ones vertical, since you use the horizontal, then vertical. So for me to get my answer, I will look for 2 on this horizontal line, and I will look for 15 on this vertical line. So this is 2, very good. But where is 15? This is up to 13, right? We open to the next page. You see that on the next page is a continuation, 14, 15, blah, blah, blah. So this is still 2 on top, and this is now 15. You then trace it to each other. Where is it touching? What's the final? 3.68. So that's the critical value for this question. Do you get that now? That's the critical value. I hope you get that. All right. But in this question, I think it gave us a 3.68. Or is it wrong? Okay, give us it's supposed to be 3.68. It's meant to be like, probably it's typographical error or something. It's meant to be 3.68. All right, so let's continue. Degrees, source of variation, sum of squares, degrees of square, freedom. The next one is going to be mean of squares. Abi? And the last one is the F. Okay, the calculated F. Now, what are the sources of variation? Your sources of variation includes your treatment. And your treatment is simply those values between the groups. And this is the first one. And the second one is within the groups. That one is also called what? Error, Abby? Okay. Do you get that? So now to fill up this space with each value of this. So let's deal with the treatment first, the between group. What's the value for sum of square for bit? That is, I'm asking for SSB. This one is SSB. For this one, the first one, SSB. This one will be DFB. This one will be MSB. I hope you get that. And this one will be SSW. This one will be DFW. And this one will be MSW. I hope you understand that. Sum of squares between the groups. Everything on this row is going to be for between the groups. So what's the value for SSB we got the other time? 17, yes, 0.445. What's the value we got for DFB? 2, and the MSB? Okay, let's go to the within the group. What's the value for SSW? DFW and the MSW. And which one is what? And this one now, 28. Point. All right, and then for F calculated, that is what's the final answer we got for the F test, which is yes, you are going to put it in between. So you get that. All right, now then I think we'll find the total here too. We'll also find the total. So what's the total when we add these two things together? Please, let's add that. What did we get? Add 176. And we'll also add this together, that's 17. Is it not? All right, so we are through with our whatever now. Yes, then you make your decision. What is our decision? Remember, our critical value is 3.68, right? Now, that 3.68 from the question, okay, 3.88. That 3.88, you are going to consider, compare it with your own calculated F, which is 3.09. Now, is this 3.0 significant? Significant. It is significant for true with our work. But if it is significant, you then go ahead and perform some operations again. If it is significant, you now use another formula. You start comparing them between A and B, between A and C, between B and C, and so on and so forth. But he cannot give us that one because 2 hours cannot be enough for it. So do it. Yes, it is. No, it's not always compulsory. You know, it makes one compulsory, but I'm not sure we'll make that one compulsory. So to conclude for this one now, the first thing I'll say is that it is not significant. Let me see. Yes, it is not significant at 0.05. I'm still going to write it. Degree of freedom is 2 and 15. That is summary of everything I want to put in the notes. This is it. Degree 2 and 15. And the critical F. In the textbook, in the question, it gave us 3.88. But remember, we got that 3.68. So now, what then do we conclude? Are we ready? Yes, it's just the summary of what I want to put in the notes. Are you ready for the note aspect? Okay. So then the note aspect is now going to be in the form of the table above, that is this table. The table above shows that a calculated F value of 3.09, the table above shows that a calculated F value of 3.09 resulted as the difference in performance of students. Resulted as the difference in performance of students due to variation in teaching methods. This calculated F value is not significant as it is less than the critical F value. You said? Due to variation in teaching methods. Full stop. This calculated F value is not significant as it is less than the critical F value of 3.68. 3.88, according to the book, of 3.88, given 2 and 15 degrees of freedom, given 2 and 15 degrees of freedom at 0.05 level of significance. At 0.05 level of significance. Hence, full stop, hence, comma, hence, comma, the null hypothesis, which says that there is no significant influence, of teaching methods on the performance of students, that there is no significant influence of counseling, of different methods of counseling. Remember, it is different counseling. We have the group 1, group 2, group 3. So instead of teaching, just cancel teaching and put counseling. Do you get? Which says that there's no significant influence, yes, of counseling methods on the performance of students is upheld. Yes. The null, remember I was talking about the null hypothesis. So those ones, yeah, exactly. Or retained, exactly. Remember I said, in case this thing is significant, you still need to perform more operations on it. However, for this question, this is where it stops. Yeah, we are true. So any comment, reaction, question? Okay, let's just take it 2020. This is the same as 2019. Okay, the question says the vice chancellor of a university is worried about the rampant cases of sexual harassment 2017-2018. This is the same as 2018-2019. So this is the same question. Can we move? Okay, the vice chancellor of a university is worried about the rampant cases of sexual harassment of female students. Among the reasons adduced for this state of affairs was the fact that there's poor value orientation among lecturers. So as a research consultant, you have to do the following. Number 1, state the topic for this study. Yes, you have to follow the rules of setting the topic now. It must contain, what are those things must contain? Yeah, it must contain a signpost. The independent and dependent variables must be there. The population must be there. And what else? Yes, so first thing first, let's note the independent and dependent variables question. What's the independent variable and dependent variable here? I believe you know what I mean by independent and dependent now. Independent is like the cause, while dependent is the effect. Yes. Independent is the cause, while dependent is the effect. You said independent variable in this question should be poor value orientation. Do you get that? Poor value orientation. That's the independent variable. Yeah, that's what is likely the likely cause would say cause would be correct. You understand? Thank you. Now, no, we are still on A. We are trying to bring out what should be in the topic. No, I understand. To get the topic, you need those variables. Okay, no. Which one? No, you don't need to write it. It's just the process of getting the topic I'm trying to explain. So we said it must contain dependent and independent variable. It must contain population. It must contain a signpost and those things. So that's what we are trying to bring out so that we can combine them together and form the topic. Do you get it now? So we have all agreed that the independent variable is poor value orientation among the lecturers, right? Then the dependent variable is the sexual harassment of female students, right? Now, okay, it's just sexual harassment now. Then the population should be the female students. And then the area of study is the university, right? So then how do we bring it together? Yes, that's what I'm trying to look at. What should we use? Should we use influence, effect, relationship? Okay, the relationship. So state your topic your own way. Let me hear. Is an effect. All right, so we are using the influence of poor value orientation among lecturers on no. That relationship. Is it? You said? Yes. No problem. So influence of poor value orientation on the rampant cases. We don't need to put rampant cases. On sexual harassment. Lecturers on sexual harassment of female students in a university, Abby? Yes, in the university.
Hello, Mayowa. Hello, Mayowa. Hello.
Yes, ma'am.
Hello.
I'm listening.
The book says that we cannot use effects or impact if it's not an experiment, if you're not experimenting yourself.
Yes, we've actually dissected that.
If you're just in a study, we should use influence.
We are trying to use influence now. Yes. Yes. Before we go on, what type of research is this first? Is it descriptive? Are we trying to describe? When will I see him? Have you forgotten the break exam? Okay, what type of research are we doing there? Are we describing? Okay. So it's description. And that means we can use influence now. So that one is gone. Influence, a case study. No, it can't be case study. Exactly. It's not case study. It can't be case study. Case study is time consuming. And case study is more or less like you going from the beginning, from the scratch. Yeah, I understand what you're saying. I understand what you're saying. No, I understand what you're saying, of course. All right, so is 1A gone? We have all agreed on that. All right, let's go to 1B. Identify two theories. The influence of poor value orientation among lecturers on sexual harassment of female students in the university. Yeah, that's the topic. The university is not stated. It's not part of this. Okay, so we can just put one university. All right, can we go to 1B? Number 2 says, identify two theories that are relevant for this study. Two theories that are relevant for this study. And theories, I think, is more or less like the external variables now, is it not? Is that not? Oh, yeah. That's true. And like she said the feminist theory, feminism. Yeah. I believe so. All right, can we move on to C? I think we are through with that. What the?
Hello,
We've
Mayowa.
stated that already now. Yes,
Hello,
I can hear you
Mayowa.
now.
Yeah, from a past question with me, they stated that the two theories can be seen in page 62, Esson textbook.
Page 62.
So if somebody has,
okay.
No, Esson.
Do you have that? Dr. Esson's book? You have it with you. It says you have page 62. The theories are there. 62, not this one. That one. Thank you. We want to check now.
Okay.
There's no theories there, Madam Koko. It's only hypothesis we are seeing there. Please, let's open to page 32. There are theories there. So we can follow the pattern there. Yes. All the theory. Can we move on to C now? All right. C states the problem of the study. State the problem of the study. State the problem of the study. So what could be the problem of this study? The problem of this study, according to you, is rampant cases of sexual harassment of male students. Do we all agree? No, we are still deliberating. We have not yet agreed on that. It's still an opinion. Rampant cases of sexual harassment. Poor value orientation is a problem because that's what is causing that thing. All right. So that's the problem of the study. The poor value orientation of among lecturers. Let's go to DOJD. The problem of the study is poor value orientation among lecturers. Now, the next one says we should formulate two null hypotheses to be tested. Two null hypotheses to be tested. Yes. There is no significant influence of poor value orientation on sexual harassment of male students, right? Okay, that's one. Another one. Yeah, we have to form two null hypotheses.
Or maybe you wanted to say hypothesis. Maybe you wanted to say formulate two hypotheses. Maybe you wanted to say formulate two hypotheses.
Instead of two null hypotheses, Abi.
I'm thinking maybe you wanted to. Yes, maybe you wanted to say hypothesis, formulate two hypotheses to be tested. Maybe that was what you wanted to say.
Is it possible? No, it's possible to have two null hypotheses now. It's possible, wow. So I'm not sure the question is yeah. Yeah, that's the first one now. There's no reason at you.
Okay. Among the reasons.
Where is it? Okay, among the reasons adduced. In our null hypothesis, is it a must that it's just these two variables that should be there? I think we can have other variables. That one is should be constant. Yes, but we can have another reason. So we can use another one now. Abi? Because this one is just one of the many reasons. Sure, you get what I'm saying? This one is just one of the many reasons. So there can be other reasons. There is no. Okay, no increase. Okay. Okay, this one is rampant. Then now there's no increase. That one can go too. All right, the next one says identify variables in each hypothesis. So the first one was no signal influence of. The first one is poor value orientation and sexual harassment. The second one is you said rampant cases and something.